Most people think CAD tools like SolidWorks, Fusion, or CATIA are just for making good-looking 3D models. But the truth is that CAD exists to answer a far more serious question. Will this part actually work before we spend time and money making it? Long before simulation existed, engineers relied on prototypes and failures. CAD changed that. To see this clearly, imagine a simple everyday situation where you design a phone stand. You sketch a shape, but before printing or manufacturing it, you rotate it in 3D, check whether it tips over, and see if the phone fits properly. Without realizing it, you've already used the core logic of CAD, visualizing geometry, checking constraints, and predicting behavior before anything is built. What's actually happening here is simple. CAD converts ideas into precise geometry, defines dimensions and relationships, and allows engineers to test assumptions digitally. Once the model exists, it can be analyzed. Loads can be applied, motion can be simulated, and weak points can be identified. This bridge from model to simulation is what makes CAD a true engineering tool rather than a drawing tool. This same logic operates at an industrial scale. Car components are modeled and stress-tested virtually. Aircraft parts are simulated under extreme loads, and manufacturing assemblies are checked for interference and motion errors, all before a single physical part is produced. Engineers use CAD-integrated simulation to reduce cost, shorten development time, and prevent real-world failure. The structured use of CAD transformed mechanical engineering by allowing design, analysis, and manufacturing to exist in one connected workflow. Instead of building first and fixing later, engineers now design, simulate, optimize, and then manufacture, dramatically improving reliability and efficiency. Now that you understand the intuition behind CAD modeling and simulation, the next natural step is to explore finite element analysis, FEA, and motion simulation, where we break down how forces, stresses, and movement are mathematically predicted inside CAD tools. And that's exactly what we'll cover in the next episode.